Hi, linear algebra students. So this is the only YouTube video you're gonna have to watch in the section 2.6. Like, remember, it's a 2-page section, right? And this is a final exam question that has been asked in fall 2018. We are given n by n matrices, and we are given that they are skew symmetric. Okay, so what does that mean? Okay, it's important to review that. So A and B are skew symmetric. What it means is that A transpose is equal to negative A, and B transpose is equal to negative B. Okay, so we need to write down this information. And we are given that AB is equal negative BA. And we want to show that AB must also be skew symmetric. Yeah, I'm gonna write it in orange here. Okay, so AB. So what do we want to show? Well, we want to show that AB transpose is equal to negative, and I'll put brackets here, but they're not really necessary, right? I put brackets just to show you that this is the definition for AB to be skew symmetric. And now that we wrote this down, we know exactly what we need to do. We just need to compute AB transpose. So that's it, AB transpose. Now remember that we're not given A and B. The only thing we're given is some of their properties. So we have to leave them as they are. We cannot just pick examples. Now, from properties of transposes, you know that this is B transpose, A transpose. Okay? And actually, Actually, let's write this as being a step number 1, because I believe there should be probably a step number 2. Then after that, we have that A and B are skew symmetric. There we go. We're using it here. So in other words, we can replace B transpose with negative B and A transpose by negative A. Now, of course, let's multiply the negatives together. We're getting B times A. Okay. And to finish the proof, it is now the time to use this information, right? So, okay, I'll be very lousy just to show you how it works. But, oh, no, not even. I don't really need to do that. So, in other words, we will have here negative of BA, but the idea is really just to write that this will turn out to be negative AB. So in other words, going from beginning to end, we were able to prove that AB transpose is equal to the negative AB that we got at the very end. And this proves that, because of what we've written down in orange, it proves that AB is skew symmetric. So I want to point out that these problems are absolutely not hard as long as you know what you're looking for, right? Otherwise, you could end up doing random calculations that you don't really understand. So pay attention to that. It's worth actually doing what I've just done, right? Writing all piece of information, what they mean in terms of matrices. All right, hopefully that helped, and see you in the next video.